Hello there and welcome back to the Science Sleepy Minds. You're floating, not just metaphorically, but in a real sense, adrift on a small blue rock spinning in a vacuum, bathed in invisible radiation and measured by a ticking wristwatch that means absolutely nothing to the stars. Outside your bedroom window, maybe it's night, maybe the sun's still up. Either way, your body insists it's time to lie down and unplug your brain. But let me ask you this. What if time, the very thing you're supposedly winding down into, isn't even real? You probably won't survive this, conceptually. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Drop a comment with where you're listening from and what time it is there. I'm curious. Are you winding down at 10:03 p.m. or spiralling at 3:17 a.m. like a philosophical raccoon? Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You trudge through the strange architecture of your daily life, where time is the architect, foreman, and utterly invisible prison warden. Your phone screen tells you when to wake up. Your stomach growls at noon as if it's signed a contract. Your calendar decides what's next in your life and then retroactively labels everything that came before. It feels real because it's organized, because it hurts to be late, because you're so deep inside the bubble it's hard to see its edges. But those edges are there, and they're weird. Let's say you're walking to the kitchen. You pass the same couch you always do, your toe grazing the frayed carpet thread that never seems to get vacuumed. In your head, the movement is sequential. First the hallway, then the fridge. But here's the thing. Physics doesn't care about first and then. At a fundamental level, all your movements could be described without ever mentioning time. Just a series of states. Toe grazes carpet, fridge opens, cheese consumed. No ticking clock necessary. The ancient Egyptians tried to tame this beast early on. They tracked the sun's daily path with shadow clocks and obelisks, slicing the day into manageable chunks. But their hours weren't always 60 minutes. They changed with the seasons. The night hours got longer in winter. Time back then was negotiable, like a friend who shows up late but brings bread. Useful, but flexible. Now contrast that with your wristwatch or phone. We've locked ourselves into atomic time, synced to vibrations of cesium atoms, flipping like a cosmic metronome. This is time turned tyrant. Precise, unyielding, and everywhere. Even your microwave blinks it at you like a smug little oracle. But here's a strange little detail. Time zones. Entirely made up. In 1884, a bunch of men, surprise, mostly British, sat in a room and decided Greenwich would be the prime meridian. Boom, the whole world got sliced into hour-wide vertical ribbons. So when your flight lands at 2:13 p.m. in Tokyo, that's just a global consensus. The Earth doesn't care, it just spins, rhythmically indifferent. Historians still argue whether early civilizations understood time as linear or cyclical. Many ancient cultures imagined time as a loop, seasons returning, kings reborn, stars rotating in eternal patterns. There was no beginning or end, just recurrence. The idea of a ticking timeline from start to finish is a relatively new invention, shaped more by industrial schedules than metaphysics. Meanwhile, your body has its own clock, an entire orchestra of chemical rhythms pulsing through your cells. Your circadian rhythm, for instance, isn't exactly 24 hours. It tends to run a bit long, like your uncle's stories at Thanksgiving. If you were locked in a cave without sunlight, your internal clock would stretch to around 24.2 hours, slightly out of sync with the planet, like you're cosmically jet-lagged from birth. And let's not ignore the ultimate timekeeper, decay. Bananas rot, your skin wrinkles, stars burn out. Entropy marches forward like a drunk god knocking over every neatly stacked pile in the universe. That feeling of things moving forward is tied not to some ticking cosmic watch, but to disorder increasing. It's not time pushing us, it's messiness pulling us. Want a weirder twist? In 1971, scientists flew atomic clocks on airplanes going in opposite directions around the Earth. When the planes landed, the clocks no longer matched each other, or the ones that stayed on the ground. That's real, experimental proof that time doesn't flow at a universal rate. It changes depending on motion and gravity. Einstein's like, told you so. Which brings us to the soft, buzzing question you're here to ask. Can the universe exist without time? To even begin to answer that, we have to peel off your day-to-day version of time like it's a name tag from an awkward conference. Because what you live isn't necessarily what is. You're experiencing time the way a fish experiences water, completely immersed, unaware of the fluid around you and probably overthinking the algae. And now that you're reclining there, sinking into your pillow, brain starting to release its grip on productivity and deadlines, I'm going to let you sit with this final image. The universe, vast and silent, exists in a state that doesn't need clocks. Planets drift, light stretches, galaxies collide over billions of years that don't feel like anything from the inside. It's all happening or not happening at once. You're the one who calls it now. You wake up not from sleep, but from the illusion that time is something you carry with you. But in truth, it's the clocks that carry you. You glance at your phone when you're groggy, 7:42 a.m. There it is again. That subtle panic. The number doesn't feel arbitrary. It feels like it has power over you, as though your entire day just got sliced up and labelled before you had a say in it. But here's the twist you didn't ask for. Clocks lie. All of them. Humanity didn't discover time. We invented ways to measure change. And then we got a little too attached. You're not moving through time like a train on a track. You're just watching your surroundings rearrange themselves. What you call 5 o'clock is just a position of the sun, an angle of shadow, a reminder that dinner needs making and emails need ignoring. Let's back up. You're a cave dweller now, no smartphone, no watch, no 8-hour workday. What tells you when to rise? The warmth of morning light across your face, the grumble in your gut, a slow shift in colour temperature of the sky. All perfectly valid markers. You're not living without time, you're just living without mechanical time. Still, everything flows, just without the tyranny of ticking. Enter the ancient Babylonians. Around 3000 BCE, these guys decided that 60 was a cool number to base things on. Why? Because it divides nicely into so many parts. Halves, thirds, fourths, fifths, you name it. So they gave us the 60-minute hour, the 60-second minute. That's not a universal law. That's just math preferences from an empire made of mud bricks. Later in the Middle Ages, monks tried to standardize their prayers by carving hours out of the day. So they built mechanical clocks in towers, sometimes so loud they could wake an entire town just to remind everyone when to feel guilty about missing Vespers. Historians still argue whether the shift to rigid timekeeping was more about religious devotion or agricultural coordination, or just monks being extra about punctuality. Then came the railroads. Oh, the railroads. You might think they were about transporting goods and people, but no, their greatest export was synchronized panic. Before trains, towns kept their own local time based on the sun's position. Noon in Boston wasn't quite the same as noon in New York. That was fine, until trains started crashing because the schedules didn't match. So in 1883, America said, "Fine, we'll make time zones." 1 year later, the rest of the world followed. With one pen stroke, entire continents agreed that their skies no longer defined their hours. Clocks did. You didn't lose an hour in daylight savings. You lost it to a meeting of men in suits who thought standardization was sexier than sunlight. There's an irony in all this. Clocks became accurate just as they became disconnected from nature. You could be in a bunker lit by flickering LED bulbs and your phone will still beep at 8 a.m. But is it morning if the sun doesn't rise? Or is your device just gaslighting you? Here's a little fringe flavour to chew on as you curl deeper under the blanket. There's a guy named John Harrison, a self-taught British carpenter who obsessed over clocks in the 18th century. Why? Because sailors kept dying. You see, to navigate the seas, you need to know longitude, and for that, you need precise timekeeping. But the sea hates pendulums, so Harrison spent decades designing a marine chronometer, basically a watch immune to the ship's rocking. His clock was so precise, it saved thousands of lives, yet the British Board of Longitude refused to pay him the prize money for years. Why? Politics, jealousy, maybe just good old British pettiness. To this day, horology nerds consider Harrison both a hero and a tragic figure, proof that saving time can cost you your own. But even the best clocks are a con. Atomic time, the gold standard today, counts the vibration of cesium atoms. Roughly 9.19 billion of these quantum wiggles equal 1 second. That's absurdly precise. And yet, who decided that was a second? We did. The atoms are just doing their thing. We're the ones who came along and said, yeah, let's measure our entire civilization by the hyperactive twitching of this metal. And don't even get me started on leap seconds. Every once in a while, scientists realize that Earth's rotation is slightly off compared to our hyperaccurate atomic clocks. So what do? They add a second, just pop it in there like seasoning. For 1 second, twice a decade, time glitches. Most people don't notice, but software engineers, they feel it in their bones. Still, you obey the clock. You show up at 9, you eat lunch at noon, and you sigh dramatically at 5. You sleep for 8 hours because some health article told you to. Never mind that your body might prefer 7 hours and an afternoon nap with a cat on your chest. Even your language betrays you. We're running out of time. Time is money. Wasted time. We speak as though time is a finite resource, a currency, something to hoard or lose. But is it? Maybe time is just change you can't ignore, a flower blooming, bread turning stale, your favourite TV show aging badly. These are the markers, not clocks, not seconds, not even the orbit of the Earth, which could theoretically wobble or stop and throw the whole calendar off. Some thinkers believe time is just our way of organising causality. This before that, effect after cause. But even that's slippery. Quantum physics has shown us events that appear to be correlated outside of time, entangled particles acting in concert with no obvious chronology. You think you're living in time, but really you're just the kind of species that likes labelling things. If someone dropped you in a universe without clocks, calendars or sunrises, would you still feel time, or would you just feel alive? So the next time your alarm screams at you or your meeting reminder pings with dread, just whisper back, "I know you're lying." Because it is. You float there, blinking slowly, starting to unhook from the day's demands. Somewhere between a half dream and a science lecture, and now it's Einstein's turn to pull the rug out from under you. You've probably heard his name more times than you've actually understood what he said, but that's okay. Most of us still imagine time like it's a treadmill we walk along, step by step, second by second. Events left behind in the past with the future arriving one tick at a time. Einstein would like a word. In 1905, Albert Einstein published his theory of special relativity, and without asking for permission, he stretched, squished, and totally bent the rules of time. You might picture him with a wild halo of hair and a gentle grin, but what he gave us wasn't soft. It was unsettling. His equations told us that time is not absolute, it's not universal, and most importantly, it's not the same for everyone. You take a casual stroll down the street, your feet pat the pavement at the same pace your heart beats, your watch ticks away, exactly as it should. But imagine a friend zooming past you in a spaceship, moving near the speed of light. According to Einstein, their watch ticks slower than yours. Not broken, just different. Time literally slows down for them. That's not metaphor, that's physics. This effect is called time dilation, and it's not some rare cosmic fluke. We've tested it. Muons, tiny particles created by cosmic rays in Earth's upper atmosphere, should decay before they ever reach the ground. And yet, they do reach us. Why? Because they're moving so fast that time for them is stretched. They live longer from their own perspective. Your idea of time as a shared communal rhythm, it crumbles right here. Historians still argue whether Einstein fully grasped the philosophical quake his equations would cause, or if he was just chasing elegant math. What's clear is that he wasn't trying to destroy our intuitive sense of time. He just couldn't make the numbers work unless he admitted something radical. That time and space are not separate. They're a single woven fabric, space-time. This isn't some poetic metaphor. Space-time is as real as your couch or your blanket. But it behaves nothing like the furniture in your living room. If you change how you move through space, your experience of time shifts with it. Go faster, and time bends. Get closer to a massive object, like a planet or a black hole, and time slows down for you. Gravity doesn't just tug on your body, it warps time itself. In 1976, a pair of physicists placed two highly accurate atomic clocks, one on Earth and one in a plane flying around the planet. When they reunited the clocks, they no longer agreed. The flying clock had experienced less time than the one on the ground. And the higher your altitude, the faster your time moves. That's right, your head is aging ever so slightly faster than your feet. So if you've been worried about getting older, good news, your ankles are slightly younger than your forehead. All this sounds wild until you realise it's baked into the tools you use every day. Your GPS system, the one that tells you how far Starbucks is from your existential crisis, relies on satellites orbiting the Earth. But those satellites are higher up, where gravity is weaker and they're moving fast. Time flows differently for them. If their onboard clocks weren't adjusted to account for relativity, Your GPS location would drift by several kilometers each day. You'd be lost before breakfast. Let that sink in. Your phone corrects for the warping of time every second. You're surfing relativistic corrections just to avoid turning into your neighborhood's most confused pedestrian. Einstein didn't stop with special relativity. A decade later, he leveled up with general relativity, which added gravity to the equation. In this version of the universe, massive objects like planets and stars curve space-time around them. Picture a trampoline with a bowling ball on it. That's Earth, curving the sheet. You're a marble rolling around the edge, pulled in by the bend, not because of a force, but because the surface itself is warped. Time bends too. The closer you are to the mass, the deeper you are in the dent and the slower time ticks for you. It's why clocks on the International Space Station tick faster than the ones on Earth, even though they're moving quickly, which slows time down. The weaker gravity they experience outweighs that. This is why, near a black hole, things get truly freaky. Imagine a spaceship hovering near the event horizon, the edge of a black hole. From the astronaut's perspective, time ticks normally. But to you, watching from a safe distance, that astronaut seems to slow down, slower and slower, until they freeze, suspended forever at the edge. From your point of view, they never fall in. But from their point of view, they fall in and are obliterated almost instantly. 2 timelines, both correct, no consensus. So who's right? That's the kicker. Both are. In relativity, there's no single, absolute timeline, no master clock. The universe doesn't have one official now that everything syncs to. Every observer gets their own version of time and the universe shrugs and says, yeah, that checks out. This is where your brain might start to slip sideways, because if there's no universal clock, what's the point of talking about the past or the future at all? You start to see why some physicists argue that time isn't something we move through. It's just a dimension like width or height. Events don't happen, they just are. Your birth, your best meal, your future regrets, all just coordinates in space-time waiting for an observer to notice. So the next time someone says time flies, you might reply, only from your frame of reference. You hover now, gently suspended in your blanket nest, brainwaves sloshing like slow syrup, and here comes the really spooky part. Not only does time behave differently for different observers, but some physicists argue that it doesn't move at all. Yeah, you heard that right. In a universe governed by Einstein's relativity, time isn't a flowing river, it's a frozen landscape. Your life, as far as physics is concerned, doesn't stretch from cradle to grave like a film reel unravelling. It's more like a whole DVD sitting quietly on the shelf. Every frame already exists. You just experience them one at a time, like a character convinced they're in motion while everything else stays still. This is the idea behind the block universe, a model of space-time where the past, present and future all exist equally. No frame is more real than the others. What you call now is just the slice your consciousness happens to be tasting. Tomorrow's already there, so is next Tuesday, so is the day you stub your toe in 2028 and rethink all your life choices. It's unsettling, isn't it? Because we live as if the past is gone and the future doesn't exist yet. But in this model, those assumptions are wrong. You're not riding time like a surfboard, you are time. Every version of you is sitting quietly in its place eternally. You at 3 years old, you crying over high school math, you just now, blinking in the dark, wondering if your mattress is secretly made of regrets and dust. You don't leave moments behind, you stack them. This model solves some weird physics puzzles. It makes sense of relativity's flexible clocks. It respects that now isn't universal, and it lets physicists treat time as just another axis on the graph, x, y, z, and t. Position plus when. Boom. Done. That's your whole existence as a neat coordinate in cosmic space-time. But if the block universe is real, it comes with some horrifying consequences. Free will? Not really. If the future already exists, how can you change it? You don't choose your next move. You simply occupy the version of yourself that made that choice. You're like a character in a flipbook thinking they've decided to blink on page 37, but the artist already drew it that way. Physicists and philosophers still argue whether this model destroys the idea of personal agency. Are you just reading from a script that's already written? Or is your awareness the thing that brings each moment into reality? Either way, you're not surfing a wave of now. You're a frozen piece of the wave, stretched across space-time like taffy. But here's where it gets even stranger. If the block universe is accurate, that means the past is still real. Not in a poetic memories live on kind of way, but in a literal physical sense. The atoms that made up your childhood bedroom are still arranged in that configuration. Somewhere in the vast architecture of space-time, your younger self is still eating cereal in pajamas that should have been burned. That moment didn't vanish. You just aren't in that slice anymore. And the same goes for the future. The old version of you, wrinkled, wiser, still misplacing your keys, is already there, sipping tea or dodging AI robots or humming to a plant in some dusty corner of your retirement habitat. That you already exists. They just haven't been activated in your consciousness yet. Kind of like a Netflix series you haven't binged yet. It's all there, every cringe scene, every twist ending. You just haven't hit play. So if the future is already real, what does that make the present? The block universe says, nothing special, just a frame, one of many. There's no moving spotlight shining on this instant to make it more real than others. It's just your current perspective, like turning your head and declaring that only the thing in front of your face exists. Now, if you're thinking this feels like philosophical doom, don't worry, it gets weirder. Some versions of the block model argue that consciousness doesn't travel through time. It's just a static feature of each frame. That's right. Your thoughts in this moment, they don't flow. They're just part of this snapshot. The feeling of continuity, the sensation of a flowing experience, is just a trick your brain plays by stitching each mental frame into a story, like a flipbook. Or, more dramatically, like a security camera that watches itself. Quirky fringe tidbit for you. The late physicist Julian Barber proposed that time doesn't exist at all. In his theory, the universe is a vast collection of nows, individual snapshots of the cosmos, each complete and timeless. He called these moments Platonia, named after Plato's idea of eternal forms. In Platonia, there's no motion, no change, just endless frozen configurations of the universe, like a galactic photo album dumped across the cosmos. According to Barber, your experience of time passing is just your mind jumping from one now to the next, leaving behind a trail of memory breadcrumbs. Like sleepwalking through a museum where all the paintings are actually you. Is that trippy? Absolutely. But it's also oddly comforting. Because if every moment is equally real, if your entire life is already etched into the space-time structure, then nothing is ever truly lost. Not the people you miss, not the places that felt like home, not even your worst decisions. They're all still there, safe in their own eternal frame, perfectly preserved like fossils made of memory. Historians still argue whether this idea is philosophy in a physics costume or legitimate science. Some say it's elegant, others call it existential catnip. But everyone agrees. It makes time feel less like a river and more like a library. So tonight, as you lie there, stretching gently into dreams, remember that the version of you listening to this already existed before you pressed play. Just like the version of you brushing your teeth in the morning, and the one who'll hear something tomorrow that changes your whole perspective. You're not on a timeline, you are the timeline, and you're floating a little now, mentally, maybe physically if your mattress is soft enough. And as your sense of time softens, the question finally surfaces. If everything we experience as time is so flexible, so observer-dependent, and so stitched together by memory and narrative, what even is time? Go ahead, try to define it. Not how we measure it, not clocks or calendars or the number of sips it takes to regret a group text, but the actual thing you're trying to measure. What is time made of? Where does it come from? Is it a substance? A process? A trick? Congratulations. You've just stumbled into one of the greatest unsolved questions in all of physics. You'd think, after centuries of pondering, charting, measuring and debating, the smartest people on Earth would have figured out the basics. But nope. We still don't have a consensus on what time is. Physicists, philosophers, cosmologists, and the occasional overly caffeinated Redditor are still locked in a cosmic group chat that never ends. Some say time is fundamental, a basic building block of reality, as real and tangible as matter or energy. Without time, the universe doesn't just stop changing, it stops existing. But others argue the opposite, that time is an illusion, an emergent property. A byproduct of something deeper, a concept we invented because we're scared of change without structure. Historians still argue whether Isaac Newton or Gottfried Leibniz got closer to the truth during their epic 17th century debate. Newton believed time was absolute. a universal tick-tock rhythm flowing steadily like water from some divine faucet, independent of anything else. He called it absolute, true, and mathematical time, and he imagined it as an invisible backdrop, moving forward whether or not anything was happening. Leibniz said, "Hard pass." To him, time was nothing but a relationship between events. If nothing changes, there is no time. Time isn't a thing. It's the way things relate to one another. No motion, no time. Like trying to measure wind without anything rustling. Centuries later, Einstein seemed to side more with Leibniz, showing that time is part of space-time, a flexible, curved geometry shaped by mass and motion. No longer the universal metronome, time became relative, malfunctioning in a way, personal, emotional almost. And then came quantum physics, and quantum physics said, "Hold my uncertainty principle." At the scale of particles and forces, time behaves like that one person at the dinner party who refuses to sit down or follow the script. In many fundamental equations of quantum mechanics, like the Schrödinger equation, time is just a parameter, not a dynamic player, not even a measurable quantity in some interpretations. The equations hum along whether time flows forward or not. You can reverse them, like rewinding a film, and they still work. In fact, most of the deepest, most elegant equations describing reality don't seem to need time at all. Time is suspiciously missing from the party. So some physicists, like Carlo Rovelli, have proposed a radical idea. Maybe time isn't real, not fundamentally. Maybe it only shows up at a macroscopic level, when complex systems, like you for example, start observing patterns and imposing order. Maybe time is just a convenient way to describe entropy, change, and causality, like putting arrows on a map that doesn't really care which way you walk. Rovelli and others explore this in something called loop quantum gravity, which attempts to blend general relativity and quantum mechanics. And in some versions of the theory, time simply disappears. There's no before or after, only a vast web of interactions, moments without order, like a shuffled deck of snapshots. Imagine a universe made of Legos, not built into structures but just floating as colourful pieces. The shape you see depends on where you stand, how you connect them, and what you decide is next. That's time, not a structure but a story you tell about structure. And your brain? Oh, it loves that story. Neurologically, your perception of time is built from memory and expectation. The reason your childhood summers felt endless and your adult lunch breaks feel like hiccups is because of how your brain processes novelty, repetition, and anticipation. Time isn't ticking inside you, it's being assembled like IKEA furniture, clumsy, error-prone, and often missing pieces. Fringe detail for tonight. There's a small but fascinating philosophical camp that believes we might be asking the wrong question entirely. Instead of, "What is time?" they ask, "What does it mean to feel time?" And what if that sensation is all there is? No external clock, no objective flow, just the experience of moments strung together by a mind that refuses to exist in a vacuum. It's like your brain is binge-watching the universe and stitching each frame into a plot, even if the universe itself doesn't care about plot development. So here's a sleepy little thought experiment. Imagine a universe where nothing moves, no particles wiggle, no atoms shift, no light travels, everything is still. Would time exist? Newton would say yes, time's still flowing even if nothing's happening. Leibniz and many modern physicists would say no. If there's no change, there's no time. It's like asking for the melody of a silent song. The notes aren't missing. They were never there. Now, bring that thought back into your room. The fan hums gently. Your heart pulses. The sheets rustle slightly as you adjust your leg for the 19th time. All of this, motion, change, perception, that's what gives you your sense of time. Not the clock on the wall, not your phone screen, you. The real ticking is internal, and when you sleep, that ticking pauses. Dreams fold time into bizarre origami. Minutes stretch, hours compress. Entire lifetimes can pass in a REM cycle shorter than your shower. Time doesn't pass, you do. So tonight, let go of the urge to measure. You don't need to understand time to drift peacefully through it. And maybe, just maybe, you don't need it at all. You're already deeper now. Your mind starting to slip through that comfortable in-between place where facts start to blur into dreams. But even here, in this hazy cradle of sleep, the question still lingers like a dust mote in a sunbeam. If time isn't real, or at least isn't fundamental, why does it always seem to move in just one direction? You never see a broken glass jump back onto the table. You've never unbaked a cookie. No matter how many movies you watch or rewind, real life doesn't let you scroll backward. Time seems to flow forward, relentlessly. That sensation is so ingrained that questioning it feels like asking whether gravity is optional. But physics, as usual, is here to complicate everything. Let's talk about entropy. Entropy is the star of the second law of thermodynamics. In plain terms, it's a measure of disorder, how messy a system is. Over time, entropy increases, always. Systems move from order to chaos. Eggs break. Ice melts. Your inbox multiplies overnight. This law is the closest thing physics has to a rule about the direction of time. It's called the arrow of time, and it's one of the only places in physics where time has a direction at all. Most physical laws work perfectly well forward or backward. There's no built-in preference. Gravity, electromagnetism, Newton's laws, even Schrödinger's equation, all of them are reversible. You can run them backward and they still make sense, but entropy always rises. That's the one-way street. You're born and your cells become slightly more disorganized every day. Stars burn their fuel and collapse. Milk mixes into coffee and never politely separates again. It's not that the reverse is impossible, it's just so ridiculously improbable that the universe might laugh in your face for suggesting it. Historians still argue whether entropy is the cause of time's direction, or just a symptom of something deeper. Is time flowing forward because the universe moves from order to disorder, or does the direction of time exist independently, and entropy just goes along for the ride? Either way, your personal timeline, your life, your memories, your entire understanding of cause and effect, follows entropy like a puppy on a leash. Let's pull on that thread. Imagine you're looking at two photos. In one, a vase is intact, sitting peacefully on a table. In the second, it's shattered on the floor. Even without context, you know which photo came first. Why? Because your brain is wired to read entropy. You instinctively associate increasing disorder with forward motion. Now imagine someone showed you a video of the vase reassembling itself, shards leaping from the floor, reforming with grace and precision. You'd know immediately that it was reversed. Not because it's impossible, but because it violates your internal arrow of time, the one built out of millions of tiny observations of eggs cracking and never uncracking. Entropy isn't just a physical law, it's part of your psychological reality. It's how your memory sorts experience. You remember the past, not the future, because the process of forming memories increases entropy. Your brain makes imprints, literally laying down physical tracks in your neurons, and the act of remembering is part of the great universal mess-making machine. Fringe fact incoming. There's a concept in cosmology called Boltzmann brains, hypothetical self-aware entities that randomly fluctuate into existence due to entropy in an otherwise chaotic universe. According to some interpretations of thermodynamics, it might actually be more likely for a fully formed brain with false memories to spontaneously appear than for the entire universe to evolve in the low entropy way we've observed. Yeah, think about that for a minute, or don't, because that's the real twist. The early universe was incredibly ordered, low entropy. Everything was compact, uniform, and tightly controlled, and ever since the Big Bang, it's been slowly unraveling like a sweater cursed by physics. That early order is what gives the universe its arrow of time, but no one can quite explain why it started that way. Some physicists argue that the Big Bang was a sort of cosmic reset button that defines time's direction. Others suggest time itself emerged from that explosion, like heat from a spark, and that before the Big Bang is a nonsensical idea. Still others propose that time is symmetric, and the universe is mirrored. Entropy increases in one direction on our side, and decreases on the other side like a temporal mirror image. But we don't see that. We see disorder increasing. We see ice cream melting, not refreezing. And every second you lie there in bed, your body releases a little more heat, a little more entropy, into your pillow. You are, quite literally, a local entropy generator in a dark room. Comforting, right? Now, let's zoom out. Imagine an empty universe. No stars, no matter, just cold, empty space. It's the final stage of entropy. Heat death. Everything's so evenly distributed, there's no usable energy left, no change, no contrast, and most importantly, no time. Because without change there is no time, no before or after, no cause and effect, just a uniform nothingness. This is where some theorists say the arrow of time dies. The universe still exists in some sense, but it has no timeline anymore. It's just a vast, still canvas, a frozen aftermath of everything that ever happened. So maybe time isn't a thing that flows. Maybe it's a function of change. You don't experience time itself. You experience the difference between now and then. You feel time in the ice cube melting, the heart beating, the words fading from your short-term memory. And here's the catch. The future isn't guaranteed to keep increasing in entropy. Maybe there's a cosmic rebound. Maybe the universe cycles back. Maybe this is just one roll of the dice. But for now, entropy gives you direction. It's why tomorrow always comes after today. Why your dreams don't play in reverse. Why your tea cools down instead of reheating itself with dignity. Time's arrow might not be carved into the bones of the universe. It might just be scribbled in its margins. But it's enough to point you forward, one cozy second at a time. And maybe that's all you really need. You breathe in, long, quiet. The fan hums, sheets rustle faintly. You're nestled in a bed somewhere on a small rotating sphere, drifting through a cosmos that might not know, or care, that you even exist. And tonight you're thinking about something cosmic, something quietly terrifying. What if the universe doesn't have a clock? And more than that, what if it never needed one? Let's back away from entropy for a moment and peer into something even stranger. Because so far, everything we've explored assumes that time is part of the game, even if it's an unreliable narrator. But a growing number of physicists argue that time might not be necessary for the universe to exist at all. Yep, a timeless universe. It sounds impossible at first. How can you have motion, change, cause and effect, existence, without time? Wouldn't the universe just be a static, frozen tableau, a kind of cosmic sculpture locked in a single moment? Well, that's one version. But there's another. What if everything, the planets, galaxies, dust motes, awkward family dinners, are just different states of the universe, all equally real, all existing at once, not in a line, but like slices of a loaf of bread? No ticking between them, no progression, just all there. This model is sometimes called the timeless universe, and it's become a real talking point in the deepest corners of theoretical physics. It doesn't mean nothing changes. It means change doesn't require time to happen. Instead of time being the engine, maybe it's just a side effect of observing difference. One way to understand it? Think of a flipbook. Each page is a complete picture. One shows a stick figure jumping, the next higher, the next landing. The pages themselves don't move, they just are. But when you flip through them, your brain creates a sense of motion, a beginning, middle, and end. What if the universe is like that? Each page, a complete timeless state. No universal flip, just endless existence, with your consciousness stitching it into a story. The trick is, no one can agree if that story is required. Historians still argue whether the idea of a timeless cosmos is simply a mathematical convenience or a truly physical feature of reality. It's become a kind of philosophical playground for modern physicists. Some see it as elegant, others as unnecessary abstraction. But it might solve a few headaches. Take general relativity and quantum mechanics. Those two titans of physics who, for the last century, have refused to share a table at the cosmic banquet. General relativity describes the universe as a smooth, continuous fabric shaped by matter and energy. It's all about curves and warps and, yes, time. Quantum mechanics, though? That's a realm of probabilities, randomness, and discrete packets of reality. It doesn't play nice with smoothness, and it doesn't treat time as particularly sacred. In fact, in many quantum gravity theories, attempts to unify relativity and quantum physics, time disappears entirely from the equations. Loop quantum gravity, for example, describes space and matter as tiny loops of energy, vibrating at discrete points. These loops don't exist in time. Instead, they are the structure of reality. Time, in this view, is just a label we attach when we move from one loop to another. It's like saying one Lego brick came before the next, even though the bricks don't come with timestamps. There's another deep theory worth whispering about tonight, the Wheeler-DeWitt equation. This monstrous equation, birthed in the 1960s by physicists John Wheeler and Bryce DeWitt, tries to describe the quantum state of the entire universe. And it contains no time variable, none, zilch. It's as if the equation shrugged and said, time, Never heard of her. In this framework, the universe just is, a static entity with all possible states encoded within it. Our sense of past and future is something that emerges only when we, as observers, interact with it. Like turning on a flashlight in a dark cave, you illuminate one part and call it now, but the rest was always there. So if you're asking, how does anything happen in a timeless universe? Well, maybe happen is the wrong word. Maybe things don't happen at all. Maybe they just exist in relation to each other. There's no cosmic clock ticking in the background, just a web of relations. State A exists, so does state B. Your brain sees B after A and says, time. But the universe never made that promise. Here's your quirky tidbit of the night. In 2018, a group of physicists proposed an experiment using entangled particles to simulate the emergence of time from quantum correlations. In their model, time appears only because two quantum systems interact in a specific way. No interaction, no time. It's as if the universe needs a conversation to begin before it starts keeping time. So maybe the real clock isn't in the sky. It's between things, in interactions, in memory, in the difference between stillness and movement, heat and cold, now and next. It's weirdly poetic, but also deeply strange, because in a timeless universe there's no beginning in the traditional sense. No bang, no countdown, no big start. Everything exists in a kind of cosmic spread, like a deck of cards fanned across the table. Some cards look like early universe hydrogen chaos. Some look like you brushing your teeth while overthinking mortality. All of them are part of the same eternal spread. And maybe you don't move across the cards. Maybe you are the card, one of many. Just a still life moment in the cosmic gallery. Does that make you less real or more eternal? You might not like the answer, but here it is. No one knows, not yet. But it seems increasingly likely that time is not what we think it is, that the universe may not be ticking away like a giant clock, that there is no before and after for the cosmos, only for creatures like you, who love stories with beginnings, middles and endings. So go ahead, drift further, you've earned it. The clock on your nightstand might blink, but the universe doesn't care. You stir slightly, not fully awake, not fully asleep, just gliding. This is the perfect state to face one of the most uncomfortable truths in cosmology. When you ask what came before the Big Bang, the universe just tilts its head and says, define before. Because here's the strange fundamental problem. If time itself began at the Big Bang, then nothing came before it. Not because it's a secret, but because there wasn't a before to begin with. Let's set the scene. You're about 13.8 billion years too late to catch the action live. But imagine the early universe. Blisteringly hot, impossibly dense, no stars, no galaxies, no Kit Kats, just pure energy squeezed into a singularity, and then bang! Not so much an explosion as an expansion. Space itself ballooning outward at a speed that makes light look sluggish. In the first fraction of a second, less than a trillionth of a blink, the universe inflated faster than you can say thermodynamic breakdown, and with it, time. That's the traditional model, the cosmic starting pistol, but the details, the ones that explain what was before that, well, that's where things get inconvenient. You see, time and space are linked in general relativity. They're like peanut butter and jelly, inseparable, though occasionally confusing. When space expands, time unfolds with it. So if the Big Bang was the beginning of space, then it was also the beginning of time itself. There was no before, in the same way there's nothing north of the North Pole. Stephen Hawking once described this beautifully. He said that asking what happened before the Big Bang is like asking what's north of the North Pole. It's not just that you can't go there, it's that the question doesn't even make sense within the geometry of our universe. Still, we humans are stubborn creatures, we keep asking. And so came theories. Many, many theories. Some physicists proposed that the Big Bang wasn't the beginning at all, that it was just the latest bounce in an eternal cycle, universes expanding and contracting like a cosmic lung. This is known as the cyclic model, and it suggests that time didn't begin, it just reset. Like hitting new game in a video game while the hard drive still holds the memory of your last 10 failures. Others suggest that our universe is just one bubble in a vast foam of possible realities, a multiverse. In this model, the Big Bang is just a local event, Time may exist outside it in some larger dimensional framework. There could be entire timelines in other bubbles, dancing independently from ours. Historians still argue whether these models are real scientific progress or just clever ways to avoid the philosophical discomfort of nothingness. But the math works, and in physics, that's often enough to keep the conversation going. Now let's get even weirder. Quantum cosmology proposes that the universe began not with a bang, but with a wave function. A timeless, probabilistic fog of possibilities that collapsed into the universe we know when certain conditions were met. That's right. Instead of a singular point in space and time, the early universe might have been a quantum superposition of all possible universes. Time didn't start ticking until an observer, or some form of irreversible interaction, forced the system to commit to a state. No tick, no tock, just fuzzy maybe universes swirling in the void of not yet. There's also the Hartle-Hawking no-boundary proposal, which suggests that the universe has no edge, no boundary, neither in space nor time. In this model, time emerges smoothly from a purely spatial state, like steam condensing into water. There's no sharp beginning, just a gradual transition from a timeless pre-bang geometry into the familiar ticking rhythm we live inside. Kind of like how your dreams slowly gain structure as you drift deeper into sleep. First, there's just vague impressions, colours, shapes, strange whispers, and then suddenly, you're riding a bicycle through your old high school in a tuxedo made of toast. It doesn't start, it just sort of becomes. Open scholarly debate continues on whether time in these models is something physical or just a construct. A few bold theorists argue that time is an illusion only in the early universe, and that once entropy kicked in, remember our messy friend from earlier, then time crystallized into what we now experience. But that early, pre-time fog, that could have lasted forever, or not at all, and we'll probably never know, because all physical traces of it would be beyond our observational horizon. Fringe fact for tonight. There's a speculative idea known as conformal cyclic cosmology, proposed by Sir Roger Penrose. In this model, each universe ends in heat death and then becomes the Big Bang of the next one. Wildly enough, some researchers claim to have found faint patterns in the cosmic microwave background, ripples from before our universe, like birthmarks from a previous life. Do we know for sure? Not even close. But it adds a surreal kind of comfort, doesn't it? The idea that the universe might be part of a longer story than we can see, that this isn't the first time everything has existed, and it might not be the last. So you lie there now, on a planet spinning through a galaxy you'll never see the edge of, inside a universe that might not even be the first edition. And behind you, nothing. Not darkness, not silence. Just no time, no direction, no before, just the sheer, quiet absence of tick. And yet, here you are. The very idea of before may be meaningless on a cosmic scale, but it still matters to you. You woke up, brushed your teeth, hopefully, and pressed play on this sleepy monologue. All that happened in a neat little order, your own personal timeline unfolding like a warm blanket. Even if the universe didn't need time to exist, you might. So for now, let before be a bedtime story, and after, that can wait till morning, you're still with me. Still floating gently, that strange pull of sleep tugging at the edges of your awareness. But your mind's awake enough to ask the next logical question. If time might not be fundamental, why do we keep using it in science? Why is it baked into every formula, graph, experiment and navigation app? Why does every motion need a timestamp, every process a duration? Even if time isn't real, we seem unable, or unwilling, to work without it. So tonight you're going to explore a peculiar contradiction. Mathematics doesn't really need time, but you do. Let's start with the strange truth. Some of the most elegant, powerful and predictive equations in physics do not require time to function. They describe what exists, how it relates, and how it behaves in ways that don't necessarily involve clocks, calendars, or before and after. These are called timeless equations, and they operate in a kind of frozen state, mapping relations between things, not how they evolve. For example, take the Wheeler-DeWitt equation. Yes, again, this stubborn ghost of quantum gravity refuses to be ignored. It's one of the most infamous equations in all of physics, and one of its most unsettling features is that it has no time variable, not hidden, not implied, just completely missing. In this equation, the wave function of the entire universe is described as a static object. Not one that evolves or changes over time, but one that is. Think of it like a giant eternal sculpture of all possible configurations of the cosmos, a mathematical snapshot so enormous and intricate that your entire life is just a speck of texture on one corner. There is no next in this model, no later, just a massive configuration that encompasses everything that could be. So why does your physics textbook have so many T = symbols? Because we cheat, not in a malicious way, more like a practical one. We build models based on what we see, and what we see are things changing, balls rolling, stars exploding, toast burning while you stare into the void. So we use time as a parameter, a useful label to keep track of which parts of the model happen when. But the deeper you go into the quantum structure of reality, the more time starts to vanish. It's not that change disappears, it's that you no longer need time to describe it. You can describe the relationship between two states, say, a particle here and then there, without needing to say which came first. It's like comparing two versions of a photo, one with the cat on the couch and one with the cat on the floor. You don't have to say which is earlier, you just describe the difference. That's the trick. Time is sometimes just a convenient index we tack onto difference. Here's a strange fringe detail for your pillow thoughts. There's a theoretical framework called shape dynamics, which tries to describe the universe in terms of the relations between the shapes of things, not their positions in time. In this model, time isn't a dimension, but a reflection of how the shape of the universe changes. Imagine watching a shadow puppet show with no awareness of time. You don't see a timeline, you just see one shape shifting into another. Time, in this context, is just the perceived difference between forms. Creepy? Maybe. Beautiful? Definitely. Historians still argue whether removing time from our deepest equations is a profound breakthrough or a misguided abstraction. After all, time works so well for us. It lets us plan, predict and panic over deadlines. It lets us model planetary motion, launch spacecraft, boil eggs. Every GPS satellite, every weather forecast, every Mars rover, all of them are using time-based physics. But here's the twist. Those systems are using approximate models, macroscopic, statistical, classical. None of them are describing the universe at its deepest layer. They're like helpful illusions, a kind of scientific prosthetic limb we've strapped on because the real thing is too weird to walk on. Even in quantum field theory, the framework that underpins the standard model of particle physics, time is treated as a parameter, not a dynamic entity. It's just there, like a silent stage manager in the wings, organising the actors but never appearing in the spotlight. In fact, some interpretations of quantum mechanics, like the path integral formulation, don't even require time to run their calculations. You just sum over all possible configurations regardless of sequence and the math sorts itself out. And yet, there's something sticky about time, something stubborn. We keep putting it back in, because while the math might not need time, we do. Our consciousness is built on sequence, one thought leading to the next, memory, anticipation, emotion, language, story. You can't think without a sense of before and after. Even now, these words are arriving one after another, not because the math demands it, but because your brain does. There's a reason you never dream in equations. You dream in moments, in sequences, in feelings that evolve. That's why science keeps using time as a tool. Even if it's not truly fundamental, it's functionally essential. It lets us translate the timeless language of the universe into a messy, beautiful, human syntax. So maybe time isn't part of the cosmos. Maybe it's part of the interface. Like the icons on your phone. They aren't really folders or trash bins, but they help you use the system without losing your mind. Time, then, might just be the universe's ultimate user interface. A comforting illusion. A tidy overlay. One that hides the brutal weirdness underneath. A reality where nothing flows, everything just exists, and the only ticking comes from your heart beating slowly into the dark. So the next time you see t = 0 in a physics paper, remember that 0 might not mean the beginning. It might just mean you started watching. You're lying so still now, the way only someone half dreaming about quantum mechanics can lie. Perfectly motionless, except for that one twitching toe that always has to rebel. But in your mind, something's buzzing. Because if time isn't part of the cosmic foundation, why does the universe feel so incredibly specific? Why does now feel so different from later? Enter quantum mechanics. the unruly little gremlin of physics. Quantum theory is where the classical world you think you live in gets turned inside out, shaken violently, and put back together upside down. It's a realm where particles don't have defined positions until you measure them, where cause and effect sometimes take smoke breaks, and where entanglement, a spooky connection between particles, transcends not only space, but maybe time too. Let's get weird. Start with something deceptively simple, the Schrödinger equation. It's the backbone of quantum physics, and, as we've already teased, it technically doesn't require time. Or rather, it includes time as a parameter, but the equation itself is symmetric, meaning it works equally well if you run time forward or backward. No preference, no built-in arrow. So why don't we see particles undecaying? Why don't we live our lives backward like some cursed art house film? Well, that depends on which quantum interpretation you subscribe to. Spoiler alert, physicists still can't agree on what quantum mechanics actually means. The math works like a charm, the philosophy, total food fight. One popular view is the Copenhagen interpretation, which says particles exist in a fuzzy superposition of possibilities until observed. Once measured, they collapse into a single state. Before measurement, everything is Schrödinger's cat. After measurement, the cat is either purring or deeply unsettlingly dead. Now here's the thing, that collapse, it seems irreversible. It gives us an arrow of time, but no one's really sure why. The math doesn't demand it, yet it happens. It's as if time emerges the moment we make a choice, or peek behind the curtain. But there's another interpretation, and it's more dramatic. Many worlds. According to this view, measurement doesn't collapse a wave function. Instead, every possible outcome happens, in its own parallel universe. You don't see the other outcomes because you split off from them, sliding silently into a new branch of reality like a page turning in a cosmic choose-your-own-adventure novel. In this model, time doesn't flow, it branches, like a tree, or a fractal, or your thoughts at 3 a.m. when you can't decide if you lock the front door. What's fascinating, and a little spooky, is that in many worlds time becomes local, meaning your timeline is just your path through a gigantic static structure of every possible universe. Change doesn't happen to the universe, it happens within your experience of moving through those branches. This idea echoes something we explored earlier, the universe as a block, a loaf of space-time slices, a vast eternal web of states. The only difference here, you're not stuck in one loaf, you're wandering through a bakery of infinite loaves, and every time you make toast, a new bakery opens. Let's make it weirder. Enter quantum entanglement. Two particles become linked in such a way that measuring one instantly determines the state of the other, no matter how far apart they are. Einstein famously called this spooky action at a distance, and he was not amused, but what's spooky isn't just the speed, it's the timing. These correlations seem to occur outside the usual constraints of cause and effect. It's not that one particle sends a message to the other at light speed, it's that both particles are part of a shared state that doesn't care about space or time. In some experiments, it even looks like measurement in the present can influence particle behavior in the past. It's called the delayed choice quantum eraser, and it's as confusing as it sounds. Here's a baby version of it. You shoot a photon at a screen with two slits. Normally it creates an interference pattern, like waves overlapping. But if you measure which slit the photon goes through, the pattern disappears, and you get two boring lumps. So far, so good. But in the delayed choice version, you wait to decide whether to measure it. You make the choice after the photon has already hit the screen, and somehow, that decision still determines whether you see a wave pattern or a particle one. It's as if the photon retroactively knew what you were going to decide. Physicists still argue whether this means information travels backward in time, or if the whole concept of before and after just doesn't apply on the quantum scale. Either way, it blows a gentle hole in your assumption that time always flows forward, and that cause must precede effect. And it gets even cozier with your pillow when you realise your brain is made of these same particles. Your thoughts, memories, feelings, they're quantum events occurring in meat space. If quantum time is weird, your subjective experience of time is just the surface ripples of a much deeper, stranger current. Fringe tidbit for tonight. Some researchers are exploring whether consciousness itself might be entangled across time, essentially smeared out, not neatly pinned to now, that your awareness could be the result of a quantum correlation between earlier and later brain states. Think of it like your present self high-fiving your past and future selves across a probabilistic field. Do we know that's true? Not at all. But it's being discussed in the same rooms where scientists casually describe electrons as both particles and clouds of maybe. So here's the quiet conclusion you can drift away with tonight. Quantum mechanics doesn't really need time. It plays with possibility, not chronology. Its deepest laws seem indifferent to direction. Its weirdest experiments suggest that the universe is far more symmetrical than your lived experience implies. And yet, you're here, breathing, thinking, remembering. You feel the now. Maybe the only reason time seems to exist at all is because your brain keeps taking quantum noise and turning it into a narrative, a timeline, a story. And maybe, just maybe, the universe keeps letting you believe that. Because it's the only way to dream. You're still here, barely tethered to waking life now, a thought drifting downstream with the current of curiosity. But even in this softened mental state, one puzzle keeps returning. If time is reversible at the quantum level, why isn't it symmetrical for you? Why does your life only go one way? You wake up, you brush your teeth, you eat the cereal after you pour it, hopefully. There's a strict order to things. But if you zoom into the math of the microscopic world, electrons, photons, quarks, it doesn't care about that order. The equations run forwards and backwards just fine. This is what physicists call time symmetry, or T-symmetry for short. In many physical laws, if you were to reverse time, flip the sign on the clock, so to speak, the laws would still work perfectly. No breakdowns, no drama, a kind of mathematical déjà vu. Newton's laws? Reversible. Maxwell's equations? Reversible. Schrödinger's equation? Also reversible. It's like the universe says, yeah, I could play this whole thing backward if I felt like it. But your body doesn't. Your memories don't. Entropy, as we've already learned, doesn't. So what happened? Well, at some point in the early universe, something broke that symmetry. This isn't just philosophical musing, it's a real phenomenon, and we have the receipts. In the world of particle physics, there's a concept called CP violation. It refers to the breaking of symmetry between matter and antimatter. C stands for charge conjugation, swapping particles for antiparticles, and P is parity, flipping spatial coordinates, like viewing something in a mirror. In theory, if you do both of those, the laws of physics should still apply. But in 1964, physicists discovered something shocking. In certain rare particle decays, specifically involving neutral kaons, cute name, extremely unstable, CP symmetry was not preserved. The decay products didn't mirror the same way. The laws behaved differently in time-reverse scenarios. And if you break CP symmetries, guess what? You break T-symmetry too. This means that deep in the subatomic jungle, time isn't perfectly reversible. Something is tipping the balance. Something is choosing forward over backward. Historians still argue whether this CP violation is enough to explain why we experience time as a one-way street, or whether it's just a tiny clue in a much bigger puzzle. Some say it helps explain why there's more matter than antimatter in the universe at all. A crucial detail considering you're made of matter and not a fine cloud of annihilated nothing. But it raises a haunting question. Why is the universe biased toward one direction of time? What's with the favoritism? Let's imagine a different version of your life, just for fun. You wake up tomorrow and suddenly everything runs backward. People walk in reverse, toast untoasts, rain flies up. You remember tomorrow, not yesterday. You say goodbye before saying hello. From a physics perspective, much of that is theoretically possible. From a thermodynamic and neurological standpoint, it's utter chaos. Why? Because you are built, biologically, chemically, mentally, to follow the arrow of entropy. Your neurons fire in one direction. Your memory systems lay down traces based on irreversible chemical changes. You perceive time flowing forward, because that's the direction your brain chemistry flows in. Your skull is basically a one-way time machine that doesn't care about quantum symmetry. But that makes the broken symmetry in the early universe even more important. Because somewhere in those first instants, when everything was blindingly hot and dense, physics picked a direction. A preferred asymmetry in the fundamental interactions of particles, and the moment it did, everything changed. Without that tiny imbalance, time might never have started flowing the way we know it. Galaxies might never have formed, stars might never have burned, you might never have tuned into this strange little bedtime monologue and asked yourself what time even is. You owe your entire experience of past and future to a microscopic imperfection, a cosmic lopsidedness. That's weirdly beautiful. Fringe fact of the night. There's a field of study looking into temporal crystals, not magic gemstones from a fantasy novel, but actual structures that repeat not in space, but in time. First proposed in 2012 and experimentally realized a few years later, these bizarre systems maintain a form of motion even in their lowest energy state. Essentially, they tick without consuming energy. Sound familiar? It should. It's the closest thing we've ever found to a real-life perpetual motion machine. And while it doesn't violate the laws of thermodynamics, it suggests that time, or at least periodic behavior in time, might be a deeper part of how matter organizes itself. We're just scratching the surface. So here you are, in a universe that was almost perfectly symmetrical, but not quite. That not quite made all the difference. It's why atoms formed, why galaxies spun, why entropy had somewhere to go, and why your pillow feels a little more worn out each night. It's tempting to think of time as a force, a current, a flow. But maybe it's something even more subtle, a bias, a slant, a gentle tilt built into the structure of reality from the very beginning, nudging everything, stars, dust, you, toward the future. You don't ride time, you slide along its slight incline, and tonight, as you drift further into that delicious nothingness behind your eyelids, remember, the laws of physics might not care which way time goes, but you do. Because in this corner of the cosmos, forward is where the story lives. You're deep now, not quite asleep, but folded into that velvet hush where the world becomes abstract. Your limbs are heavy, thoughts come slower, softer, but still. One question bubbles up like a lazy air pocket in a still pond. If time is a directionless optional variable in the math, and entropy is just a tendency toward mess, then what if time isn't real at all? Like, at all? You've already heard whispers of this idea, that time might be emergent, that the universe doesn't come with a built-in clock, but now it's time to lean into one of the strangest possibilities in modern theoretical physics, that time is a thermodynamic zombie, not truly alive, just acting like it is because of entropy. Let's unpack that sleepy nightmare. You start with what you know. Time feels real. It has flavor, texture. It tugs at you constantly. The future looms, the past lingers, and yet, the only physical process that seems to give time a direction, the arrow, the flow, is entropy increasing. So what if time is just that? A byproduct of increasing disorder. In this view, time isn't fundamental. It's like steam rising from a hot mug, an emergent phenomenon, not a core ingredient. When the universe is ordered, time doesn't exist. But as disorder creeps in, time appears, like a shadow cast by heat. Think about that. Your sense of moving through time, it's just your brain interpreting entropy gradients. Change happens, disorder spreads, and you mistake that for movement. In reality, nothing's moving, nothing's ticking. You're just passing through slices of increasing statistical chaos. Historians still argue whether entropy alone can account for your full experience of time, especially memory, anticipation, and choice. But the model is compelling. You can describe the past as low entropy and the future as high entropy. Everything you remember happened in a state of lower disorder. Everything you expect is drifting toward decay. But that's just statistics, not physics, and that's why some physicists describe time as a thermodynamic epiphenomenon, something that emerges when you zoom out far enough, like how a rainbow emerges from light and rain. There's no rainbow particle, no rainbow force, just an emergent illusion built from simpler ingredients. Time might be the same. So if that's true, if time is a statistical illusion, a narrative your brain tells you as it watches entropy rise, then what does that make you? Here's where it gets freaky. There's a school of thought in physics called relationalism. It says nothing exists by itself, only in relation to other things. Position, velocity, mass, even time, they only make sense when you compare one object to another. There is no universal ticking clock, just change and comparison. You aren't in time, you're a web of changing relations, and your experience of time is just a story your mind composes from those changing relations. Fringe tidbit for tonight. There's a speculative concept called the Page-Wouters mechanism, named after physicists Don Page and William Wouters. They proposed a quantum system where the global wave function is static, frozen in time, but when you observe a part of the system, it looks like time is flowing. In other words, time might not be real globally, but it can emerge locally from entanglement between subsystems. You only feel time because you're a tiny part of the cosmic whole, peeking through a pinhole. Zoom out far enough, and nothing's moving at all. It's like a DVD. The whole film is already printed. All the scenes exist simultaneously, but your DVD player, your consciousness, moves through the frames one by one, creating the illusion of time. And if that DVD is the universe, you're the red laser, not the movie. Now let's return to Entropy. It's been your uninvited roommate this whole time, your cosmic breadcrumb trail. But entropy itself doesn't require time to exist. In fact, entropy is just a statistical description of probability. You don't need a ticking clock to say that a shuffled deck is more likely than an ordered one. You just need options, more microstates than macrostates, more ways to be messy than tidy. That imbalance is what drives the illusion of time. Imagine a universe at perfect equilibrium, where everything is the same temperature, everything evenly spread. No gradients, no flow, just silence. In that universe, there would be no clocks, no memories, no change, no time. You couldn't age, you couldn't move. So maybe the only reason time exists at all is because we're not at equilibrium yet. Because the universe is still unraveling. The weird twist. That means time might not just be an illusion, it might be a temporary one. A kind of cosmic hallucination that only lasts until the entropy party's over. Then what? Well, then nothing. Not silence, not darkness, not peace. Just no more time. No then. This is what some physicists call thermal time hypothesis. The idea that time is tied to temperature differences, energy flow, and irreversible processes. In this model, when the heat dies out, the clock stops ticking. The universe doesn't end, it just stops changing. And if nothing changes, there's no more story to tell. This is the heat death scenario. We've mentioned it before. A cold, thin soup of radiation and decay, spread so evenly that no new structures can emerge. It's not death in the dramatic sense, it's the death of narrative. Everything flattens out, entropy maxes out, and the illusion of time vanishes with it. That's the ultimate irony. Time doesn't end in fire, it ends in balance. So tonight, as you lie warm and safe in your own tiny thermodynamic pocket, this cozy little human-scale entropy bubble, know this. You exist because the universe is still unwinding, because the dice haven't stopped rolling, because the sugar hasn't fully dissolved into the tea. You are the ripple, the difference, the imbalance. That's what makes you capable of remembering, thinking, dreaming. It's not time flowing through you, it's you flowing through change. And when you finally drift off into sleep, your brain will do something remarkable. It will shut off your awareness of time almost completely. You won't feel it moving. You won't track the hours. You might wake up with no sense of whether you've slept 8 hours or 20 minutes. That gap, that's what timelessness feels like. So go ahead. Let your sense of time dissolve. Let your brain lose its place in the narrative. You're not missing anything. You're just visiting a place without clocks. It's quiet now. Your breathing is slow. Your thoughts half submerged. You're somewhere deep in the folds of the universe's narrative. Except, as we've been unraveling for hours now, that narrative might be nothing more than your brain's comforting little bedtime fiction. A sequence imposed on chaos. A plotline constructed from the raw material of entropy and memory. But tonight, we step fully into the realm of the unimaginable. Could the entire universe be timeless? Not poetically, not metaphorically, but fundamentally. Welcome to the timeless universe hypothesis. It's not a metaphor. It's a literal proposal that everything, the planets, the stars, the embarrassing thing you said in 6th grade, your yet-to-be-eaten breakfast, already exists in a vast, unchanging structure. Not frozen like a moment in time, but complete like a crystal. Intricate, unfolded, every possibility fully real. This is the culmination of everything we've been building toward. If time isn't a fundamental component of reality, if it's not in the deepest equations, not in quantum gravity, not even in the early universe, then the next logical leap is terrifyingly elegant. The universe doesn't need time, it simply is. This isn't just a fringe idea. Many modern physicists, especially those working in quantum gravity, are now exploring what a fully timeless cosmos would look like. In these models, change is not a movement through time. It's a relationship between different configurations. It's like flipping through photographs. The photos don't change. You do. Let's go deeper. Imagine reality as a vast configuration space, called configuration space, because naming things dramatically helps us pretend we understand them. This space contains every possible arrangement of everything. Every particle, every atom, every breath you'll take tonight, every alternate version of you who took a left turn instead of a right. Each configuration is called a now. All the nows exist simultaneously, not in time, in structure. The best analogy is geometry. A triangle doesn't change, it's just a shape. The triangle doesn't have a past or a future, it simply exists. The timeless universe works similarly. It's not a story playing out, it's a shape that contains all stories. Physicist Julian Barber, yes, we're invoking him again, championed this view in vivid philosophical tones. He argued that time is an illusion created by change, that every moment you think you've lived through is just a separate static point in a landscape of moments. Your brain stitches them together and calls it life. He calls this structure Platonia, a timeless realm containing all possible nows, not drifting, not moving, just eternally present. Each now is complete. Each one is as real as any other. You're not moving between them. Your consciousness simply resides in one. You think you're experiencing time, but you're really just aware of one now, and then another. But in truth, they all already exist. Fringe detail for your dreams tonight. Some of these nows don't include you at all. Some are empty universes. Some are stars just starting to form. Some contain dinosaurs, or no life at all. Some contain you, but slightly different. One breath off, one neuron misfiring, one decision changed. In this model, there's no becoming, only being. It's not a progression, it's a structure, a vast eternal object. Your story isn't told, it's contained. And you're not living through a life. You're simply located in the part of Platonia where your life appears. This, of course, messes with everything we've built our minds around. It obliterates causality, undercuts free will, and turns history into a strange kind of sculpture. You're not making choices. You're just in the part of the structure where those choices appear to happen. Historians and philosophers still argue whether this model implies fatalism or simply reframes reality. Some say it's terrifying. Others find it profoundly calming. After all, if every now is equally real, then nothing is ever truly lost. Every moment you've loved still exists, somewhere in the structure. Your first kiss, that one perfect night under the stars, even the dream you'll have tonight, already there, already real, just not now, or not your now. Now here's a sleepy twist. This model might also solve some of the measurement problems in quantum physics. If all possible states exist, then there's no need for wave function collapse. Measurement doesn't choose a result, it simply locates you in the part of Platonia where that result was already real. It's not that you observe the outcome, it's that the outcome defines where you are. Everything becomes location, not sequence. That's the heart of the timeless universe hypothesis. You're not moving through time, you're located in a part of an unchanging structure, the part that feels like right now, but that also means there's nothing truly separating you from the future, or the past, or the alternate versions of your own life. They're not behind you or ahead of you, they're simply elsewhere, and if that's true, then maybe, just maybe, nothing is ever really gone. Now, as we slow our thoughts to the softest crawl, let's let go of questions for a moment. Let's just feel it. Imagine Platonia, a vast, timeless expanse of moments, each one still, each one silent, each one complete, no motion, no ticking, no waiting. Your entire life already is, every version of you already is. The universe didn't happen, it happens to be, and that's enough. So now, let everything soften, the concepts, the questions, the restless need to understand. Let your thoughts stretch out long and slow like shadows at sunset. There's nothing more you need to grasp tonight. You've been wandering through deep questions, but now, it's time to just be. The air around you feels thicker now, heavier but safe. Your limbs feel distant. Your mind isn't racing anymore, it's floating, like a leaf in a warm breeze. Time may not be real, or it may be. But here, in this moment, what matters is that you feel still, whole enough. Let the universe spiral on, timeless and strange. Let entropy do its slow, quiet dance. Let your breath anchor you to a now that's gentle and kind, and let your body drift down, into sleep. You're not fully here anymore, and that's okay. You're hovering now somewhere between the last thought and the next, between the now you just heard and the one you're sliding into, which, if we're being honest, is the perfect mental posture for this next step in our slow spiral through the nature of time. Because now we need to talk about something deeply personal, your brain. Not in the philosophical sense, but in the squishy biological, how the heck do I remember birthdays but forget why I walked into the kitchen sense? Tonight's question is simple but strange. If time might not be real in the universe, how does your brain make it feel so real? Let's rewind to the basics. You, right now, experience time as a continuous stream, a ribbon. 1 second flows into the next. You remember what just happened. You expect what might come. But here's the secret, that sensation isn't built in, it's constructed. Your brain doesn't actually feel time. It manufactures the experience of time from memory, attention, and, here's the kicker, prediction. You're not watching time pass. You're building the illusion of a passing moment from tiny neurological pieces. And guess what? Sometimes your brain gets lazy, or creative, or both. Take memory. We think of memory as the record keeper of time, your personal archive. But your brain doesn't store memories like files in a cabinet. It rebuilds them, reconstructs, edits, sometimes even rewrites. Every time you remember something, you change it just a little. And every time you forget something, your brain still fills in the gap with something that feels right. That's not time passing. That's time being reassembled. Historians still argue whether human memory evolved primarily to recall the past or to simulate the future. Some cognitive scientists now believe that memory's main job isn't to remember, but to imagine, to predict, to let you run simulations of tomorrow using pieces of yesterday. So when you lie in bed, thinking about what might happen next week, or replaying an awkward conversation from last Tuesday, you're not stepping into the past or the future. You're just reconfiguring mental patterns. There is no clock in your brain. There is no time organ. There's only perception, and perception can be fooled. Ever had a dream that seemed to last hours, only to wake up and realize it had been 15 minutes? Or ever looked at a clock and for a split second it seemed to freeze, like the second hand paused? That's a glitch in your time perception system. It's called chronostasis, and it happens because your brain tries to smooth over the gap created when your eyes move. You think you saw continuous time. You didn't. You saw a patch job. Even cooler? Time perception changes with emotion. Scared. Time slows down. Bored. Time drags. Happy. Time flies. That's not physics. That's neurotransmitters, limbic systems, and hormones creating the illusion that the clock is moving faster or slower. But the clock isn't doing anything. You are. Here's your fringe tidbit for the night. In 2007, researchers discovered that our brains have at least 2 separate internal timing systems. One operates over short intervals, milliseconds to seconds, like when you're keeping a beat or predicting when toast will pop. The other deals with longer spans, minutes to hours to days, and it's connected to memory, attention, and emotion. 2 clocks, neither made of gears, both unreliable, and yet somehow your brain creates the impression of a flowing, orderly timeline. Now there's something else your brain does that's even sneakier. It edits the now. You think your experience of the present is immediate, but studies show there's actually a delay on the order of a few hundred milliseconds between the moment something happens and the moment you become consciously aware of it. During that gap, your brain is buffering, filling in blanks, adjusting for sound delays, visual input, muscle feedback. Your now is not the real now. It's a composite, a guess, a reconstruction of reality, stitched together just in time for your attention to catch up. It's like watching a live stream with a tiny bit of lag, except the stream is your life, and the lag is your consciousness. So now we're deep in it. If time is just something your brain infers, pieced together from memory, prediction, and sensory lag, then how much of what you think is time is just the echo of your own thoughts? Your brain isn't tracking a cosmic clock, it's navigating itself. And that brings us to the uncomfortable intersection between physics and psychology. Maybe the sense of time is purely subjective, a hallucination triggered by complexity, a story you write to make sense of change. It might even be necessary. Consciousness, as far as we understand it, requires context, continuity, an experience of cause and effect, a sense of me then and me now. Without time, there is no identity, just input, chaos, static. So maybe your brain invents time not because the universe demands it, but because you do. Because without it, you couldn't function, you couldn't be. Here's a soothing thought to end on. If time is something your brain creates, like music, or colour, or dreams, then every moment of peace you feel, every second of joy, every blink of awe, isn't just something you lived through, it's something you made, not a recording, a creation, a masterpiece stitched together from neurons and memory and change. So tonight, as your thoughts dissolve into soft fragments and your brain releases its grip on the ticking, you're not just falling asleep, you're letting go of a story your mind's been telling all day and slipping into a place where time once again stops being something you watch and returns to what it truly is, a feeling. You're not dreaming yet, but you're close. Thoughts drift in loops. You forget what you were just thinking. Time blurs, stretches, flickers, and right there, in that slippery space between awareness and sleep, something quietly profound is happening. You're entering a state where time doesn't work the same way. Dreams aren't bound by seconds or minutes. They skip, compress, loop. In one dream, you're back in your old school, then suddenly on a train that's also somehow your childhood bedroom, and the moon is a vending machine that only dispenses regret. You feel like time has passed. You wake up and say, that dream lasted forever. Or sometimes, wait, was that it? But how long did it really last? Probably less than 2 minutes. Dreams reveal one of the strangest truths your brain is capable of exposing. You don't need time to have experience. And that, more than almost anything else, might be evidence that a timeless universe isn't just a mathematical possibility. It's something your brain visits every night. Let's start with a simple observation. Dreams are not played out in real time. They feel like they are. But neurologically, they're happening in compressed packets, almost like flash fiction. The narrative is often retrofitted after the fact. Your brain might create the memory of a full-length dream in just a few seconds of REM sleep. This means that the story of the dream, beginning, middle, end, is often manufactured instantly. A complete simulation of time that was never actually experienced in sequence. You think you lived it. You didn't. Your brain wrote it. Historians still argue whether dreams serve a cognitive purpose, like memory consolidation, emotional regulation, or low-stakes problem-solving, or whether they're just the idle screensaver of a resting brain. But either way, dreams consistently show us that your sense of time is deeply flexible, fragile, invented. In waking life, you rely on continuity, external cues, consistent sensory input, gravity, light, routine. But in dreams, those cues are missing. So your brain improvises. It builds a makeshift reality using memory fragments, abstract logic, and an oddly generous suspension of disbelief. And part of that construction? A simulated sense of time, not clock time, dream time, and it's like jazz, structured in feeling but not in rules. Want a fun fringe tidbit? In some studies, lucid dreamers, people trained to become self-aware inside their dreams, were instructed to perform time-based tasks while asleep. Things like counting to 10 or tapping their fingers a certain number of times. Researchers tracked their eye movements to determine when they started and stopped the task. What they found was incredible. For many tasks, the subjective time it took matched their waking pace. But for others, time ran longer or shorter. Some people counted faster, some slower. Some stretched seconds into what felt like hours. Meaning, even with conscious awareness inside a dream, your brain doesn't keep reliable time. It estimates. It paints. Time in dreams is like distance in a painting, suggested, not measured. And it gets even stranger when you realize that some dream sequences seem to fold time. You fall asleep, dream of growing up, of raising kids, of growing old, and then wake up to find only 10 minutes have passed. Or you have a dream with flashbacks, flash-forwards, non-linear loops, and none of it feels wrong in the moment. That's because your dreaming brain doesn't require linear time to feel coherent. It only needs sequence. Not 1 second after another, but one idea after another. A chain of impressions that feels like causality, even when it's just randomness wearing a plot hat. This is where the timeless universe hypothesis meets your subconscious. Because if your brain can simulate a fully immersive experience, one that feels like time is passing, without any real passage of time, then maybe that's all time ever is, a deeply convincing sensation of change linked together by memory. Think of dreams like private visits to a personal Platonia, a version of that timeless configuration space we explored earlier. Each dream is a moment, already complete, not played forward, but entered. You don't watch it unfold, you wake up into it, and then it vanishes, a memory of time without actual time. Even your emotions obey different clocks in dreams. You feel grief in an instant, relief without build-up, dread that spans years in a matter of heartbeats, love that doesn't need a courtship arc, because dreams don't run on duration, they run on density. The experience is packed in tight, like a song that hits you in the first two notes. So if dreams are timeless experiences that feel like they had time, how different is that really from waking life? That's the big whisper in all of this. If your brain can simulate time in sleep, what's to say it isn't doing the same thing while you're awake? Building now, predicting next, remembering before, all without a ticking universe behind the curtain. Maybe waking life is just dream logic with longer refresh cycles. Maybe the only difference between a dream and reality is that you agree more often with the rules when you're awake. So here's the final thought for tonight's descent. Your brain has always known how to live outside of time. It does it every night. It does it when you nap, when you lose yourself in a book, when you watch someone you love and forget for a moment what day it is. These are your natural experiments in timelessness. Proof that what you call time might just be a kind of conscious choreography. Your mind stitching together thoughts in a way that makes sense to itself. But beneath all that, stillness. The universe might not tick, it just waits. And you, sleepy, dreaming, human you make the ticks as you pass through it. You make the rhythm, and then you dance. You're so far gone now that words feel less like language and more like soft footsteps echoing down a hallway you've forgotten you built. Still, somehow, you're here, breathing slowly, anchored in this strange bedtime thought experiment that just keeps unraveling. And tonight, the next quiet revelation floats in like moonlight through a half-open window. The moon doesn't know it's night, seems obvious, but sit with it for a second. Because that's not just a poetic observation, it's a reminder of something fundamental. The universe has no concept of time zones, calendars, or whether you're calling this moment late. It just exists, silently, endlessly. While we scramble to divide the sky into hours and argue over daylight savings, let's zoom out. Time, as we experience it, is deeply Earth-centric. Our concept of a day comes from a single planetary spin. A year is one orbit around the sun. Even a month loosely traces the moon's cycle, though we eventually squash that into an awkward 12-piece pie chart that barely fits the math. But all of these units are local quirks. On Mars, the day is 24 hours and 39 minutes. On Jupiter, it's only about 10 hours. Venus rotates so slowly that one day there is longer than its year. And Mercury? Oh, Mercury! It takes 59 Earth days to rotate once, but because of its weird orbital resonance, a solar day, sunrise to sunrise, lasts 176 Earth days. Which means if you were standing on Mercury, waiting for the sun to rise, you'd get a lot of reading done, or go insane, or both. So let's ask the big question. What is time, if it depends entirely on where you are? Here on Earth you live by the rhythm of the sun. But the sun doesn't rise or set. It's us, spinning, orbiting, wobbling, tilting. And we slap numbers on those cycles to give ourselves a sense of continuity. But that's all it is, numbers. Clocks aren't measuring time, they're measuring change. A swing of a pendulum, a flick of an atom, a turn of a gear. Nothing in the universe is ticking. We've just picked certain repetitive motions and called them seconds. The moon, meanwhile, has never once looked at its reflection in the ocean and said, "It is currently 2:17 a.m. in Portugal." That's your story. The moon has no concept of time. It simply reflects light, moves through gravity, causes tides. It's a silent participant in our illusion, like a character who never learns the plot. Fringe detail, the moon actually causes Earth's rotation to slow down very, very gradually. Hundreds of millions of years ago, Earth's days were only about 21 hours long, and it's still changing. In about 200 million years, a day will last 25 hours. So if we insist time is fixed, whose time are we talking about? The planet's, the sun's, yours? Because you, dear human, are a chaotic cocktail of biology and perception. Your circadian rhythm, The internal clock that tells you when to sleep, eat, cry at insurance commercials isn't exactly 24 hours. It usually runs a little long, which means if you lived in a cave with no clocks or sunlight, you'd gradually fall out of sync with the sun. Your body doesn't even agree with your planet's definition of a day. Historians still argue whether ancient timekeeping was more about practical needs, agriculture, trade, survival, or spiritual symbolism. Most likely it was both. The earliest sundials weren't just tools, they were altars. Measuring shadows wasn't about punctuality, it was about reverence, trying to read meaning in the changing sky. Even now, time feels spiritual. You celebrate birthdays, mourn anniversaries, worship the new year like it means something more than another full orbit. You give time shape, emotion, weight. But again, the moon doesn't care. It pulls at your oceans with the same indifference it shows to your calendar app. It doesn't know it's Monday, or 2025. It doesn't even know it's a moon, it just is. You're the one who told a rock it was your sister. You gave it names, measured its cycles, built stories into its silence, which leads to a quietly radical idea. Maybe the passage of time is less about reality, and more about relationship. Time is how you relate to motion, to memory, to the light on your wall at dusk, to the sound of your neighbour's footsteps every morning at 7:12, to the fading of a scar, to the growth of a child's laugh, to the silent arc of the moon above your roof. But none of these things require time. They require difference, change, contrast. Time is how you describe the contrast, how you narrate it. You're not swimming in time, you're floating in contrast. Time is your vocabulary for the shift. So what happens when those reference points vanish? Astronauts on the International Space Station orbit Earth every 90 minutes. They see 16 sunrises and sunsets each Earth day. So what's evening for them? What's Thursday? They have to simulate Earth time artificially, standardize their clocks to coordinate schedules, but their bodies struggle. Circadian rhythms go haywire. Time becomes more psychological than environmental. Reality becomes internal, and when astronauts sleep, time stops meaning anything at all. So maybe the moon has it right. Maybe the universe doesn't care about your hours and your schedules and your end-of-quarter deadlines. Maybe time is just the costume you drape over change to make it feel like a plot instead of a storm. And in that way, the moon is wiser than we are. It just obeys gravity and reflects light and remains. So as you lie here, letting your thoughts slow and your breathing flatten into rhythm, remember, there is no universal night, no agreed upon now. Only your body, your mind, and the moon outside your window, unmoved by your calendar, unaware that you're calling this late. And still, you look up at it and say, it's time for bed, and the moon says nothing, but pulls at your tides just the same. The moon fades behind your eyelids now, its pale glow replaced by something even older, deeper than science, more ancient than atomic clocks or quantum mechanics. Something carved into stories long before time meant hours, or seconds, or scheduled Zoom meetings. Tonight, as your body folds into stillness, you're going to listen in on a different conversation. Not between scientists or satellites, but between ancient minds and eternity. Because long before anyone asked if the universe could exist without time, human beings were already wondering, what is time and why are we trapped in it? Let's start in the East. In Hindu cosmology, time isn't a line, it's a wheel. Not the linear birth-to-death trajectory familiar to the modern West, but a great repeating cycle of creation, preservation, and destruction. Everything exists within enormous units called yugas, ages that span millions of years. Entire universes are born, flourish, decay, and collapse, only to begin again. No apocalypse, no end of time, just the wheel turning. In this worldview, time is real, but cyclical, recurring, and that means you too recur. Life isn't a one-shot narrative, it's a repeating pattern, with karma shaping your return, like a cosmic reset button with moral consequences. Fringe detail. One full cycle of 4 yugas is called a Mahayuga, and it lasts about 4.32 million human years. After 1,000 of these, Brahma, the god of creation, blinks. And when Brahma blinks, the universe vanishes. When he opens his eyes again, it returns. So yeah, even your deity has a refresh rate. In Buddhism, time becomes even stranger. The Buddha wasn't all that interested in physics, but he did explore the illusion of continuity. According to many Buddhist schools, the self is a mental construct built from ever-changing processes. There is no enduring soul, just impermanence. And with that impermanence, a kind of timelessness emerges. There's a concept called the momentariness of existence, the idea that everything arises and passes away in discrete fleeting moments. The world doesn't flow, it flickers. You aren't a solid self. You're a fast, refreshing stream of sensations and thoughts. Time isn't something you move through. It's something that appears only because you cling to continuity. Let go, and the illusion dissolves. That's not so far from certain interpretations of quantum mechanics, or Julian Barber's timeless configuration space, which is wild considering the Buddha was not using tensor calculus. Meanwhile, halfway across the world, the ancient Greeks were also staring at time with suspicious eyes. Take Heraclitus, the philosopher best known for saying, "You cannot step into the same river twice." He saw the world as a process of constant flux. Change was the only constant. And while that sounds like a pro-time stance, it's actually more subtle. For Heraclitus, what we call time isn't an external flow. It's a metaphor for becoming. You're not in time, you are time. You are the becoming. Then there's Plato, who described time as a moving image of eternity. To him, the physical world is a shadow of the true, eternal realm of perfect forms. Time, in that sense, is a distortion, necessary for change and perception, but not fundamental. Plato gave the world the idea that time is a created thing, a kind of moving reflection of something timeless. And his student Aristotle took a different angle. He defined time as the number of change with respect to the before and after. In other words, time is how we measure change, not a thing in itself, but a relation. Sound familiar? Modern physicists still argue whether Aristotle had it right 2,300 years ago. Jump ahead to early Christian theology, and time becomes moralized. Life becomes a line, from creation to fall to redemption to judgment. There's a start, middle, and definitive end. This teleological view, time with a purpose, shaped Western thinking for centuries. The idea that we're going somewhere, that time has a direction, a goal, and a final act. But even here, timelessness creeps back in. In many mystical traditions, the goal of spiritual life is to exit time, to reunite with the eternal. Heaven is often imagined not as an endless duration, but as a state outside of time altogether, unchanging, eternal, serene. No clocks and no minutes, just is. That's not far from the ancient Gnostics, who described time as part of a cosmic trap, a mechanism created by a lower god to keep souls bound to illusion. For them, salvation wasn't just forgiveness, it was escape, from time, from decay, from the endless spin of matter, and now here you are, lying still, listening to a digital voice whisper ancient thoughts through the artificial glow of your phone screen, which ironically is powered by technologies that function without time variables in their core equations. You're a strange convergence of history and theory, a being whose culture tells you that time is a resource, something you can waste, manage, sell, or run out of, but whose body tells you that time is rhythm, pulse, breath, cycles, sleep, and whose mind occasionally dares to wonder, what if the ancients were right? What if time is just one lens, a useful illusion, a story told around the firelight before memory? So as your breath slows even more and the gentle hum of your fan becomes the only metronome that matters, think of all the ways humanity has tried to explain this one mystery. The wheel, the flicker, the river, the illusion, the exile, the dream. And maybe none of them are right, or maybe all of them are, different metaphors for something that never wanted to be measured. Because in the end, time might not be a fact, it might be a language, and tonight, you've become fluent in silence. You've slipped so far from the waking world now that even your thoughts are starting to forget their names. Shapes melt into sounds, time slows into stillness. But just before you vanish completely into that quiet nowhere, let's open one last door, a door into something almost unbearably strange. What if time isn't just an illusion, but a trap, a cage, a script you can't rewrite? Because tonight we're going to entertain one of the most unsettling ideas in all of modern theoretical physics and philosophy, the possibility that you're not moving through time. Time is moving through you. Let's start with something we've teased all along, the block universe model. In this view, as you've heard before, time doesn't flow. All events, past, present, future, exist equally. The universe is a frozen, four-dimensional structure, and your experience of moving through time is just your consciousness surfing a static wave. But tonight, let's ask a new question. If the block universe is real, are you just a puppet? Because if your future is already there, fixed in the fabric of space-time, then you're not deciding anything. You're just living out the part of the structure where those decisions appear to happen. There's no free will in a block. There's only you following the line drawn through your existence like a bead sliding along a wire. Some physicists don't love this implication. It stinks of determinism, but others embrace it, even when it makes people squirm. They say, look, the equations describe all of reality as a structure, not a process, not a story, a shape. So what feels like you choosing something? It's just the part of the structure that contains that version of your thoughts. The rest of your possible decisions, they exist too, just elsewhere in the block. Fringe theory time. Some physicists and philosophers argue that consciousness itself may be a function of your location in space-time, that your sense of self, your awareness, your memory, all of it is bound not just to your brain, but to your coordinates in the block. You don't ride the train of time, you're just the window seat at a specific section of track. Now, for the brave, imagine that this version of you, the one listening to these words, breathing this air, settling into this bed, is already complete. Every breath you've taken, every decision, every hesitation, etched into space-time like a statue, not becoming, just being. You don't exist in time, and you're a fixed point inside time. But here's the real chill. You can't see outside of your own slice. You feel like you're moving. You feel like time is flowing. But that's just the illusion projected by your own neurological structure, a sensation wired to interpret one frame at a time. Think of it like a flipbook again. The stick figure feels like it's dancing, but it's not. Every page already exists, every motion already drawn. The dance is in the viewer, not in the figure. You are the figure. And maybe, just maybe, you're not the one flipping the pages. Historians still argue whether time's passage is an emergent property of consciousness, or if consciousness is an emergent property of time's passage. Either way, the loop is tight. Wherever time goes, so does identity, so does story, so does the illusion of choice. And if it is an illusion, then what's the point of anything? Why make choices if they're already made? Well, that's where it gets weirdly hopeful, because even if the block universe is true, and even if your choices are fixed, the experience of living them isn't. You still feel them. You still suffer and love and learn and laugh and ruin pasta and stare at stars. The richness of the moment doesn't depend on whether it's truly free, it just depends on whether it's real. And if the moment is real, so are you, even if you're a puppet. Because the puppet still feels the sun on its face. Let's go one layer deeper. In some interpretations of physics, especially in computational theories of the universe, time might not just be illusory, it might be computationally emergent. That is, time is what happens when the universe computes its next state. But the computation isn't sequential, it's relational. It happens all at once, and your experience of time is just your brain's way of walking through the code line by line. You're not the author of the script, you're the cursor, the blinking point of focus as the code runs. Still there, still aware, but with no access to the rest of the program. Another fringe thought. In some views of simulation theory, time might only exist for the players, not for the system. That is, if the universe were a simulation, we're not saying it is, but we're also not saying it. Time would be a user interface, not part of the hardware, just a convenience for the experience, like a progress bar or a loading screen. Time is how you make sense of state changes, but the changes, they were already rendered. You're just walking through them, like a ghost in a maze that doesn't move. You're not being chased. You're just noticing the walls in a specific order. So what does this all mean? It means time might be your greatest illusion, your deepest myth, the thing you call life, but which is actually just a guided tour of a statue. And if that's true, then your job isn't to break free from time, because you can't. You're not its prisoner, you're its puppet, and a puppet doesn't escape the strings. But maybe, just maybe, it can dance. So tonight, as your final thoughts blur into dream fog and your sense of now thins into nothing, let go of the pressure to do anything. Let go of the illusion of control. Let go of the schedule, the goals, the fear of running out of time. You can't run out of something that never existed. You're not on a timeline, you're a fixture in space-time, and you are enough, just as you are. Still, complete, unfolding, frozen, dancing. At this point, you're barely holding on to the shape of thought. Consciousness has softened. Even the idea of now feels distant, like a blurry photo of a memory you never quite lived. And honestly, that's perfect. Because we're down to the final threads now, the most peculiar, persistent question of all. Why does modern physics keep trying to delete time? It's not a conspiracy, it's not a grudge, it's just a recurring theme, a strange pattern that emerges again and again when physicists attempt to stitch together the biggest theories of existence. So tonight, as you settle into the soft folds of sleep, let's take one last tour through the science of why time keeps vanishing. To begin, let's revisit the problem we've been dancing around this entire script. General relativity and quantum mechanics do not agree. They are both incredibly successful. They've given us GPS, smartphones, black hole imaging, quantum computing. But when you try to combine them into one unified theory of everything, things go sideways. In general relativity, time is a flexible, warping dimension. It bends near mass, it stretches, it slows. Time is part of the fabric of reality. In quantum mechanics, time isn't a player, it's a backdrop, a parameter, a non-negotiable ticking coordinate against which all other processes are measured. It's assumed, not explained, a fixed timeline upon which probabilities evolve. These views are fundamentally incompatible. You can't have a theory where time is both absolute and malleable. So when physicists try to merge these theories, usually in the form of quantum gravity, they're often forced to do something radical, remove time entirely. Let's start with a name you've met before, the Wheeler-DeWitt equation. This monster of theoretical physics attempts to describe the quantum state of the entire universe. But something's missing from this equation. You guessed it. Time. The equation doesn't evolve. It doesn't tick forward. It doesn't predict next. It just is. Like a frozen snapshot of every possible configuration of reality, existing outside of any clock. This leads us to a troubling thought. If time isn't in the ultimate laws of physics, why do we experience it so vividly? Fringe fact for tonight. Physicist Carlo Rovelli, a leading voice in quantum gravity, has written extensively about this. He suggests that time may not be a fundamental ingredient of the universe at all. Instead, time may be an approximation, something that emerges only when we zoom out like temperature or colour. Microscopically, the equations don't need time. Macroscopically, time appears. It's like watching a movie. At the pixel level, it's just flashes of colour and light. But when you lean back, characters move, stories unfold, and time flows. So maybe your life is the macro illusion. Maybe the entire universe is already complete, and time is just your way of watching it unfold, frame by frame. Historians and physicists still argue whether it's even possible to build a coherent reality without time. Some say yes, pointing to timeless formulations of quantum gravity. Others argue no, insisting that time is required for causality, choice, and change. But here's the twist. In trying to remove time, physics might actually be uncovering why we need it so badly. Because when time disappears from the equations, something else has to explain motion, emergence, story. And more often than not, physicists are forced to fall back on the thing we talked about back in section 6, entropy. Change doesn't happen because of time. Change happens instead of time. Time becomes the shadow of transformation, not the cause, not the ruler, and just the impression left behind when a system becomes less ordered. It's not a clock, it's a consequence. Even the thermal time hypothesis, a speculative idea in theoretical physics, proposes that time doesn't exist fundamentally, but emerges from the thermodynamic properties of a system. The hotter, messier, more chaotic a system gets, the more time we seem to feel. Time becomes temperature's twin. So why does modern physics keep trying to delete time? Because it keeps discovering that the things we've attributed to time, change, motion, aging, sequence, can be described without it. And not only that, those descriptions often work better. It's unsettling, sure, but it's also elegant. Because a universe without time doesn't mean a universe without change. It means a universe where change is primary, and time is the story we tell to explain it. You're not aging because time is passing. You're aging because your cells are changing, your molecules are rearranging, your entropy is increasing, and your brain, trying to make sense of all that, says, this must be time. But it's not. It's just difference. Difference written so smoothly, you call it memory. So what does this mean for you? Well, maybe nothing, or maybe everything. If time isn't fundamental, if it's just a cognitive illusion or an emergent phenomenon, then you're free to stop racing it. Stop fearing it. Stop measuring your worth by how much of it you think you've used well. Because there was never anything to race in the first place. No river pulling you downstream. No clock counting down in the sky. Just change. Just being. Just you. Experiencing one configuration of the universe, one after another, like flipping through stills in a gallery you were born inside. So tonight, let this final image settle in your soft, drifting mind. The universe is silent, still, complete. Time doesn't push it forward. There is no forward. There is no when. Just stars, just matter, just possibility. And you, suspended perfectly inside it. Not ticking, not moving, not waiting, just existing. One shimmering configuration at a time. This is it. You're barely conscious now, floating in a space so quiet even the idea of thought seems too loud. Your mind is soft and open, like moonlight on still water. No edges, no urgency. Just the final, gentle slide into one last impossible question. If time isn't real, then what are you? You've been asking big questions all night. Could the universe exist without time? Is the past still real? Is the future already written? But now, at the edge of everything, we turn inward. Because if time isn't fundamental, if everything you know is just a flickering sequence in a timeless landscape, then your identity, your story, yourself, what are they exactly? Let's go slow. Let's feel it. You experience yourself as a timeline, a progression. Childhood to now, morning to midnight, one thought after another. But if the universe is timeless, if all possible moments already exist, then you're not a story. You're a structure, a complete four-dimensional object. Not a soul passing through time, but a pattern in space-time. Just like a mountain is not moving through geography, you are not moving through time. You are the mountain, a fixed shape in the landscape of the universe. You're not a being that was or will be. You're a being that is, in its entirety. Every version of you, sitting in class, laughing in a car, crying in the dark, listening to this script right now, is already etched into the structure. Nothing is waiting to happen. Nothing is lost. It's all there. You don't become complete at the end of your life. You're already complete. Right now, always have been. This is the most disorienting and oddly comforting idea in physics, that your existence is not unfolding, but unfolded. A single object with depth in space and extension in time. Like a loaf of bread where every slice is one of your moments. Not separate, not sequential, just part of the whole. And yet, inside your experience, something does move. Something tells the story. Something watches the frames flicker by and says, I am me. I was there. I will be there. Who is that? Who's reading the book of you, one page at a time? Some say it's consciousness. Some say it's illusion. Some say it's a kind of temporal inertia, a story engine, running on memory and expectation. But the deeper you go, the more it slips through your fingers. It's not in the math. It's not in the matter. It's not something you can explain. It's just the feeling of being here, now, listening, wondering. And if that you is just a viewpoint in a timeless universe, then maybe identity is just a way of navigating difference. Maybe self is what it feels like when a system reflects on itself, when one configuration of the universe becomes aware of its own shape. You're not separate from the universe. You're one of its shapes, one of its thoughts. And that means you're not just a passenger, you're part of the pattern. Every thought you've ever had, every whisper, every memory, every pang of regret, every laugh that turned into a wheeze is encoded in the structure, not lost, not waiting. There, always. You're not a timeline, you're a territory. And this moment, this now, isn't more real than any other. It's just the one you're conscious of. And when that consciousness fades, nothing is erased. It's just that attention moves. Elsewhere, somewhere, or maybe everywhere at once. Fringe detail, one last time. Some physicists speculate that consciousness may not be confined to one moment in time at all. That what you call now is just the part of your awareness that's been tuned in. That the rest of you, your other moments, are still alive in the structure, like photos still developing in a dark room outside of your view. If that's true, then every version of you exists in parallel, not like alternate universes, like different rooms in the same house. You're not walking through the house, you are the house. And this room, the one where you're falling asleep listening to these words wondering if time is real, this room will always be here. So don't worry about holding on. You can't fall behind. You're already whole, already finished, already here, and now. Let it go. Let time dissolve. Let yourself dissolve. Let every moment stretch out into stillness, because the show is over, the lights are dimming, and your name has already been written into the script of space-time. All that's left to do is sleep.